And we can take some questions, if there are any, but I suspect people may be. Yes? Takes like 4 seconds for it to.
Thank you for a nice presentation, Jesper, Sebastian, Mads, and Paul. I have comments for the presentation made by Mads, comments for your presentation. And first of all, I would like you to understand the physics in the fuel cell. So basically, methanol is taken through 5 steps. Step number 1 in the fuel cell is that it's heated from ambient temperature, let's say 15 degrees to 68 degrees Celsius. It's on a liquid state. Step number 2 is to transform the methanol from being a liquid to being a gas, from 68 degrees Celsius to 68 degrees Celsius as a gas. Step number 3 is to heat the methanol as a gas from 68 degrees to approximately 140 degrees Celsius using the waste heat from the fuel cell. And the next step is to burn a little bit of methanol in order to superheat the methanol from 140 degrees Celsius to approximately 250 degrees Celsius. And at that temperature, you can use the catalyst in order to split methanol into carbon monoxide and hydrogen. So that is step number 5. And finally, then you can take the hydrogen and put it into the fuel cell. And here it's of really high importance that you understand that the low temperature PIM fuel cell is operating at approximately 8 degrees Celsius. You have to have a handful of nines. So that is, you have to have 99.999% pure hydrogen. Otherwise, the carbon dioxide will kill the fuel cell, just like carbon monoxide kills us as human beings. But only by increasing the operating temperature from 80 degrees to 160 degrees, then you increase the carbon monoxide tolerance by a factor of 1,000. So instead of having a handful of nines, 99.999, you can use less than 99% pure hydrogen. And this is of immense importance. So that was the first step, and that was my comment to Mads' presentation. And what Serenity is doing with the methanol is the exact same thing as Leslie is doing with the combustion engines, utilizing the syngas as the fuel instead, with a 19% higher heating value. So that was my comment number 1. Comment number 2 is referring to your really nice presentation. I really liked it. And you mentioned the analysis made by Volvo quite some years ago. And I really like that comparison made by Volvo as well, and I really digged into it. But Leslie, again, back in 2010, wrote a really nice report called Methanol as an Alternative Transportation Fuel in the US. And I would like to read the 2 lines from page number 50 in that report, saying, a detailed investigation of the overall efficiency and greenhouse gas emissions of fossil and alternative fuels was performed by Volvo, as you said. They have assumed that the methanol engine has the same efficiency as the gasoline engine. And all of us know by now, by all the presentations made by Martin and Jacob, Jesper, and so on and so forth, Sebastian and so on, that this is not the case. So they made a false assumption in their work. And I would like all of you to point this out whenever you see this presentation and this comparison, because it's a false assumption. Obviously, all of us know that the efficiency on methanol can be much higher, diesel-like efficiencies. And finally, I've digged into the potential of alternative fuels. And in 2010, according to the International Energy Agency, there are 7 billion inhabitants on Mother Earth. And we were consuming more than 90 million barrels of crude oil per day. Yep. And that is 108 etajoule of energy. At the same time, we have a biomass potential of Mother Earth of approximately 200 etajoule. And in the future, in 2050, one believes that the energy consumption for transport will be approximately 168 etajoule. This is again according to the International Energy Agency. And obviously, if we need 168 etajoules of energy for transport, and we only have a biomass potential of 200 etajoule, the numbers do not add up. And therefore, the conclusion made by the International Energy Agency is, and I will read again, biofuels can provide up to 27% of world transportation fuel by 2050.
Absolutely.
And my analysis shows that they are wrong. So the International Energy Agency's analysis is wrong, and we can actually produce all we need if we take 3 steps. And I call it 3 E's. So step number 1 is from index 100 down to index 150, and that is efficiency. So by using a more efficient fuel, by using downsizing, turbocharging, variable valve timing, all of these technologies. We know the technologies, we know what they cost, we know how big the CO2 reduction is. So that's step number 1, from index 100 to index 50. Step number 2 is electrification. And that can actually not take us that far. It can only take us from approximately index 50 to index 40. And that is electric vehicles, battery electric vehicles, plug-in hybrid electric vehicles, electric trains, metros, trams, and all of this. But obviously we cannot electrify aviation, and we cannot electrify ships that is going to transport containers from China to Europe. So it can only take us from index 50 to index 40. And finally, the last remaining 40%, that has to be electrofuels. And by electrofuels, I mean that we take biocarbon with a carbon ratio in biomass. So this shirt and this table and the carbon has a carbon ratio of 1 to 2. But by adding hydrogen from renewable sources, like we do here in Iceland, we can double the potential and thereby decrease the amount of biomass we need in half. And by taking these steps, there is actually plenty of biomass potential available worldwide. And instead of producing by 27%, we can eliminate the use of fossil fuels in 2050. Thank you.
I thank you for your comment. And we really want to welcome that kind of vigorous thinking and participation, and that's definitely helpful. I appreciate that. Mads, did you want to make any comments about the fuel cell piece? Or?
No,
Fine.
great.
Sure, just respect that. Well, very good. I think we've had a lot of information to digest, but I think this will serve us well going forward. So again, I want to thank each and every one of you, and we'll adjourn until the second global conference in this regard. Thank you very much. Wow, success.
I forgot the question.